Up next on the docket, section 4.2, which is about logarithmic functions, more generally about logarithms. What the heck is a logarithm? We're going to have to do some setup here first before we do anything else. It's definitely related to exponential functions, and in some sense, well, it's what we call an inverse function, so like a reverse function. So it's an inverse function to an exponential function. So the exponential relationship is involved and is important, but it's sort of coming at it from a different perspective. Let's do some stuff. Let's just sort of set up what the form is that we're working with first. So if we have the exponential relationship, well, let's run it the other way. Let's set up what the log is going to look like. So if we have, so the logarithm, which you're going to use the abbreviation log, logs have a base, just like the exponential functions have a base, and so it shows up as a subscript on the log. So it's the log base b, so it's sort of type b of x is equal to y. So this is the log base b of x is equal to y. So what this means as an exponential form is that if you take the base value b and raise it to the y, so the y value is your exponent, what you get back is the value x. So the log base b of x equals y means that if you take b and you raise it to the y, you get back to this x value. So in theory, what we're doing is we're really asking ourselves when we have a logarithm is, what is the exponent that you need to put onto the base number to end up at this value x? It's this little puzzle. What's the power that you need to get to x if the b value is your base value? Let's just sort of take a minute and go back and forth between exponential forms and logarithmic forms, sort of forwards and backwards. Let's start with the exponents because that's kind of what we're familiar with, and then we'll sort of turn them into logs. So back and forth between these two forms. And we'll kind of track, right, where these different numbers go and where the different values go. So what's a common exponential value? Let's just do something pretty simple. Let's take, right, 4 squared is 4 times 4 equals 16. I wonder if I should, well. So what is this going to look like as a logarithm? Let's see. So the idea here, right, is 4 is our b value, 4 is the base. The exponent, right, the 2 here, is going to be our y value. That's sort of where we're ending up. And the x, which in this case is the 16. So that's going to be what we're taking the logarithm of. So what this is going to look like, so this becomes log, so the base of the log is the same as the base on the exponent, so it's log base 4. So again, that's like a subscript, like log sub 4 of, so it's going to be of 16. So we're trying to get from 4 to 16. So it's the logarithm of 4, I'm sorry, the logarithm base 4 of 16. And so then what it equals to is whatever our exponent is that connects those two numbers together. So it's 4 squared, right? 4 raised to the 2 is going to get us to 16. So if I started with an exponential form and I wanted to write it as a log, I would do log of the base value, log base value of the result sort of equals whatever this exponent is, right? So you're sort of shifting around the positions of all of these things. The thing to avoid, right, it's not the log of like 4 raised to the 2. So it's not, you know, it looks like this is 4 raised to the 16 or something, right? So the thing to watch out for is that you're not calling this 4 raised to the 2 equals 16 and just rewriting the original exponential version of it just in throwing a log in front. The relationship here is different. So you're trying to get from 4 to 16, and you're asking yourself, what is the exponent that I need to get there? Let's take another one. Let's say, if I start changing up the powers a little bit, right? What about something like, 3 to the negative 1? So, like, what the heck did we get if we do a negative 1 power? Well, what we get if we do negative 1 power, right, is 1 over 3 to the 1, 1 over 3. So that's going to be 1/3. Right. So the exponential version is 3 raised to the negative 1 equals 1/3. So then, as a logarithm, this is going to become, I'll just do the full log in red, I suppose. So it's the logarithm. So the base value is the same as the base value on the power, so it's base 3 of the result, right? So the question is, how am I getting from 3 to 1/3? And maybe what I should be doing here is sort of putting parentheses around these values, right? It's the log of 16. The base here is 4. So how do I get from 3 to 1/3? What's the exponent that's going to connect those two together? And the answer, right, is using a negative 1, right? Negative 1 is going to make this into a reciprocal, so I'm going from 3 to 1/3. I'm just flipping it over. So my log equals negative 1. So to get from 3 to 1/3, the exponent I need is this negative 1. And that's going to be that. If we do, right, if we get a little bit clever with some other different types of powers, we could do, fraction powers, different like root type powers. So take something like, let's do square root. Right, so the idea is something like the root of 25 equals 5, right? How do I write a square root as an exponent? All the different roots are going to involve fraction exponents, right? So a square root is a 1/2 power, a cube root would be a 1/3, a fourth root is a 1/4, and so on and so forth, right? So how do I get from 25 to 5? What's the power? So it's whatever power would give me a square root, and that power is going to be 1/2. So 25 raised to the 1/2 equals 5. So then as a logarithm, what this is going to look like is, so the logarithm, my base value, right, the value that's receiving the power here is 25. So this is the logarithm base 25. My goal, the number I'm going to end up at, is 5. So how do I get from 25 as a base back to 5? The answer is I need to do a square root to get from 25 to 5. And so what is the power that does a square root? The power, right, the exponent, is 1/2. So the log base 25 of 5 equals 1/2. Let's see if we can flip this relationship around a little bit and try to sync it up. So going from a log form into an exponential form. So let's try to run this going the other way. Again, the numbers have this same kind of positioning that's happening, right? We're sort of keeping everything, at least as far as like the location. The locations here are being consistent. So let's kind of flip this order. And let's go log form to exponential form. So let's start with a logarithm that I know is true, and see if we can kind of justify this by rewriting it as an exponent. What should we do? Let's do the log base 2 of 8. And let's think about this for a minute, right? So what does this mean? This is 2 is the base number, and then I'm trying to get from 2 to 8. So what's the power on 2 that's going to get me to 8? It should be 3. 2 cubed, right? 2 times 2 times 2 is going to get me to 8. So I'm saying log base 2 of 8 should get us to 3, should equal to 3. So becomes, as an exponential, so what's this going to turn into? So the idea is I'm saying, okay, so 2 raised to the 3, so my base value is 2. the number over here is the exponent, so 2 raised to the 3. And the idea is, yeah, of course, 2 raised to the 3, 2 cubed is going to be 8. That totally works out. These two things are consistent. So just trying to practice going back and forth between these two forms. What we're trying to build up to is being able to just evaluate logs on their own without having to be sort of given all three of these pieces of information. And to a certain extent, to do that, honestly, what we're going to be doing is kind of just reverting back to this exponential form. At least for me, I'm always kind of mentally converting back to an exponential form just to make sure the numbers make sense. Let's do another one. Let's do 3 as the base again. And let's do log base 3. And let's do log base 3 of 1/9. So the idea here is I'm trying to get from 3 as a base value to the result 1/9. Now obviously, right, 3 squared is 9, but this isn't just from 3 to 9, which would just be the power is 2. It's 1/9, right? It's the sort of fraction version. So that means it's a combination of squaring and it's this reciprocal value, right? It's flipping and sort of shifting from a numerator into the denominator. So it's going to be 2, but it's going to be -2. And so let's double check this. So this is going to become, right, so the idea is this is 3 to the -2. So that's going to be 1/3 squared. 1/3 to the +2 would be 1/9. So this stuff all fits together. This is kind of acting and doing what we would hope it would do. This is sort of getting us where we want to go. Let's do one more. Let's do some sort of root. How about log? Well, I tell you what, let's not do a root. Let's do something a little bit trickier. How about log base 6 of 1. So the question here is, well, what's the exponent that I'm going to use to get from 6 to 1, right? How do I get from 6 to 1? And the answer is right, anything raised to the 0 is going to become 1. So log base 6 of 1, how do I get from 6 to 1? The power has to be 0. So if we double check this in the exponential form, this should be right, 6 raised to the 0 equals 1. And that totally checks out. That's exactly what we would expect. So if we're given kind of all three of these values, right, either shifting from exponentials to logs or vice versa, this is the way they all connect. This is the relationship between all of them. So that's a starting point. What we're going to do next is just evaluate logs having this sort of exponential form as a reference, but we need to be able to just sort of come up with log values where we're missing some of these numbers. So that's going to be next.